Please start, Neeldhara.
Okay, that's great. Good evening, everyone. Thanks to those who are joining us live. So just again to be sure, it will be great if you could just react with a +1 or a hi if you can see us and hear us right now. And our plan is to begin by sort of addressing a popular request that has come up in Discord and also through the form that was circulated, which is essentially to go over some hints or basically general insights for the programming questions on week 2. So we will start there and then we will switch to any questions that come up in the live chat. Hi there, Bhupati. It's great to see you. So thanks for joining. So let's maybe start with the week 2 questions, the week 2 programming assignment, start from there. So Arjun, it's all yours.
Sure. Okay. So I'll just recap and alongside I also refresh my memory of the problems. So we'll start from week 2 problem assignment 1. So in this problem, you're given an integer n and k, and you're given an array a1 to an. Initially, all the values are guaranteed to be between 1 and 10 power 9. And then you can make some modifications. And what are modifications? In a single modification, you can choose a contiguous segment of the array of size k. You can choose any of the k consecutive segments. You can call it subarray, or you can call it a subsegment. And if, say, you choose ai to ai plus k minus 1, I2, I plus k minus 1 is of length k, right? So if, say, you choose this, then in this subarray, suppose the minimum value is some min, right? Let's just call that variable min. Then what you're allowed to do is you can change all the elements in that segment from whatever elements they already were to the value of min, right? So this is what one modification entails. And what are you supposed to do? You're supposed to do, your aim is to convert all the elements. Sorry. My bad. So after selecting the subsegment, suppose the minimum value is min, then all the elements which are min, which are equal to min, right? So say my segment is 2, 4, 5, 2, 3, right? 2, 4, 5, 2, 3. Suppose k is 5 and I have a large array and I've chosen this subarray, which is 2, 4, 5, 4, 3. The minimum value in this is 2, and 2 occurs twice, right? So 2 occurs in the first index of the subarray and also in the fourth index of the subarray. What I'm allowed to do is convert these two values, these two 2's, to 10 power 9 plus 1, right? So basically in the subarray, you take all the minimum values, you convert them to 10 power 9 plus 1. Right? So this is one modification you can do. And the aim is to convert all the elements of the entire array, all the n elements, to 10 power 9 plus 1. And the question is, what is the minimum number of modifications you need to do so? Right? So this is the problem. If there are any doubts about the problem, please do ask. Let's just have a look at the chat once. Okay. Neeldhara ma'am speaks very fast. Interesting. Okay. So coming back, so this is the problem. So I think the first observation you make is that changing it to 10 power 9 plus 1, so you need to ask yourself, what is the significance of this number 10 power 9 plus 1? The significance, of course, is the fact that the input elements, that is the original array, has all elements from 1 to 10 power 9. And so any modification you make is going to be 1 more than the largest number, right? So anything that you change, I mean, if in this example, I took a 2 and I changed it to 10 power 9 plus 1. So now, once I change it to 10 power 9 plus 1, now this will not be the min of any future segment I take, right? So once I've changed it to 10 power 9 plus 1, and this also I've changed it to 10 power 9 plus 1, these two elements now become greater than all the other unchanged elements, right? So that is the first observation, or the first, it's not even an observation, the first significant point that you see, right? So now the question is, forget. So whenever you see a problem which asks you to find the minimum number of ways to do it or minimum steps to do it or something, the first thing you ask is, okay, forget about the minimum number. Let me just think of some way in which I can get the final answer, Right? The final answer should be all elements being 10 power 9 plus 1. So for now, forget about minimizing the number of modifications you do. Just think of any way, take as many steps as you want, as many modifications as you want. Can you always convert any given array into the final array? Right? Let's call 10 power 9, all elements being 10 power 9 plus 1, let's call it the final array, right? So the first question is it, does the question make sense, right? So for the question to make sense, it should be the fact that given any array, I should be able to convert it into this final array. So given that you kind of like do a backward logic and say that because there's a question given, it should make sense, right? The question probably makes sense because it said that thought of this. So there should be a way to convert any array to this. If not, usually the problem will have a line of the form. If you can't reach the final answer, output -1, something of that sort will usually exist. But in this problem, we see that there is no such thing. So it's probably the case that no matter what the input is, we'll always be able to reach the final array. So the first step is to then think of this, right? So convince yourself, or rather think of an algorithm, a constant, like a process by which you can convert any given array into this final array, right? That should be the very first step. And I think this, just thinking of this, should give you an intuition into what exactly you do with these modifications, right? So take, if you just first, my suggestion would be to first think of this kind of sub problem. If it still is not very clear, just take an example, take some 10 size array, take k to be, I don't know, 5, and work it out by hand, right? So take any subarray, convert it, see what exactly is happening. Take some other subarray, like keep making these changes. So you'll see that the number of elements which are 10 power 9 plus 1 will always kind of keep increasing. And the aim is, after some number of modifications, you get it to all of them being 10 power 9 plus 1. But of course, this is easy to say, but you have to think of exactly how you would go about doing it. So this should hopefully not be a very hard step. Once you've done this, then the next step, it's a hint, it's not a step. The hint I would give is basically think of each value separately, right? So that is, in this example that we took, we saw there were 2 2s, right? Instead of just looking at these 2 2s, look at all the 2s in the array, right? Then look at all the 3s in the array, then look at all the 4s in the array. Like whatever distinct values are there, think of them kind of separately, okay? And see, maybe is there any way to do to solve the same problem kind of independently for each different value. Okay, so separately solve it for all the 2s. It doesn't make sense because the 2s are all kind of, there'll be a 2 here, there'll be 2 here, there'll be 2 here. So what does a subarray even mean in this context? It's not very clear. But think along these things, right? So so the major hint right now is basically think of the problem for distinct values independently, and then think of how you can club them together. So, but what exactly it is that you do for each distinct value, I don't want to tell it out very explicitly, but I think this is the thought process which should hopefully lead you to the correct answer. Yeah. I'll look at the chat again.
I think the chat is mostly banter so far, but I would request anybody who has any comments or would like to get any clarifications or dig deeper into anything specific, this would be a good time to post in the chat.
Yeah, I just need to know that the solution I was talking about was for the 100% solution, but there are 3 subtasks in this problem. Subtask 1 n is 10, subtask 2 n is 1000, and we have 10 power 5. But for subtask 1, it's more of just a brute force approach in some sense. But to be frank, I think coding that is going to be harder than coding the final solution. Subtask 1 is kind of just like a catch subtask and not exactly a very intentional easy solution being for that. Subtask 2 rather is a pretty decent subtask, but the thought process for that still goes along the approach that I said. So you'll have to think of what I said, but implementation will be easier in subtask 2. For subtask 3, you have to work a bit more to get to subtask 3, but hopefully that should not be too much of an issue if you are comfortable enough with the language. Is it possible? Okay. Cool. So I'll wait for 1 more minute and then we'll go on to week 2 assignment 2.
Yeah, I just also double checked Discord and I think the questions were fairly general. I think it was mostly calls for hints or how to approach the problem. So I think this covers it pretty much.
Sure.
So yeah, I think.
Okay, so then we can move on to the next problem.
Yeah.
I'm able to write Spurti. So I think the way to figure out whether the algo you have is the intended algorithm is mainly through time complexity and memory complexity to a smaller extent. I would definitely suggest that you think of the time complexity of your algorithm before writing the algo. Maybe write it down in a small piece of paper, like the outline or the pseudocode or whatever you want, or just think of it in your head. And first figure out what the time complexity of your algo is, and then substitute the constraints and check whether it is within 10 power 8 operations per second, which is the usual rule of thumb. Right? So if it is more than 10 power 8, if it is like 10 power 10, it's probably not the solution which we are looking for. So you should try to optimize your algo better. It need not be just optimizing the algo. It might be a separate algo which is just more efficient. Yeah, so that's basically the answer. Hope that helps. Cool. So now moving on to week 2 assignment 2. You're given an integer n and an integer m, and again an array a1 to n. You need to find the smallest positive integer k such that ceiling of a1 by k plus ceiling of a2 by k dot 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 ceiling of an by k is less than or equal to n. Right? So the question is, what is the smallest value k such that this expression is less than or equal to a value n? So let's kind of just dive into this. So what is ceil? Ceil is basically the ceiling function, right? So ceil of 2.5 is 3, ceil of 3.7 is 4, right? So you round up. Ceil of 5 is 5, it's not 6, right? So if it's a fraction, you round up to the integer just above it. If it's an integer, you just leave it as it is. That's the ceiling function. So, so let's take the expression and just substitute some random values of k and see what happens. So suppose we substitute k equal to 1. Right. So what do you get? You get ceil of a1 by 1. And what is a1 by 1? A1 by 1 is just 1. Right. So ceil and ceil of a1 is just a1 because a1 is an integer. So by 1, everything is going to be the same. So ceil of that is going to be the same. So for k equal to 1, the expression you get is just going to be a1 plus a2 plus a3 up till an. Right. Now, if you increase k, then it becomes ceil of a1 by 2 plus ceil of a2 by 2, and so on. Right. So the values are kind of halved. It's not exactly halved because you have the ceiling function as well. But what you can be sure of is that ceiling of a1 by 2 is definitely less than or equal to ceiling of a1 by 1. Right? It can never be greater than this. Right? If I divide by a larger value, even if I take a ceiling, it's going to be less than equal to what I would get when I divide by a smaller value. Right? So think of this a bit. It should be intuitive enough, but if you want to actually sit down and prove it, it should not be very hard to do so. Okay, it's simply the fact that the ceiling function itself is monotonic. Right. So what is a monotonic function? I hope you know what a monotonic function is. It's a function whose value increases as the input increases. Leaving aside like less than equal to strictly like you have less than equal to versus less than, but let's not get into that thing. But that's what we're looking at, right? So because the ceiling function is this nice function, then this entire expression also is going to keep decreasing as you increase k, right? So k equal to 1, you get a1 plus a2 up till an. You make k equal to 2. Each term will become less than or equal to. So the whole thing is also going to become less than or equal to. K equal to 3, it will be even less than, like even further smaller, and so on and so forth, right? So so you start out with some value, it reduces, and what do we need to find? We need to find the first time that this value becomes less than or equal to a given value m, right? So think of, like, you can visualize it like this. You say you have a like a large, like a number line. Think of the number line vertically. I don't know why I'm thinking of it vertically for some reason. Okay, so you start out with a1 plus a2 up till an. Then you divide by, you change to k equal to 2, so it drops down. K equal to 3, it drops down further, drops down, keeps dropping down. And the first time it becomes, so there is an m here, the first time it goes beneath m, that value of k is what you want, right? So this is the problem. So how do you go about solving this? So I think here the subtask is a fairly easy subtask to solve, which is basically just simulating this. So you can just simulate exactly the same process that I said right now. That is, take k equal to 1, then k equal to 2, and so on and so forth, and find the first time when you get the expression to be. Each time, evaluate the expression. So how do you evaluate C? Okay, so that's maybe some of you are stuck at that point. So I'm fairly certain all languages have an inbuilt function which returns C of x by taking x as input. Right? So I think that's the simplest thing to do. Or you can write your own function, but just learn. It's also good to learn your language, what all capabilities your language has to make life easier. So I would recommend just looking up, Googling seal function in whatever language you have, and utilizing syntax. You might have some library and so on, but it should definitely work. So for subtask 1, it's simply basically taking different values of k, increase k, and the first time, and each time you evaluate the expression, the first time it becomes less than or equal to m, that value of k is your answer, and you just output it. Right? Let me just make sure that was the intended solution. Yeah, that is the intended solution. Yeah, so that should work for 30 points, 30 out of 100 you should get if you do that. Now for the whole subtask, the aim is not to do it one by one, but something more efficient. And I think I'll just give one simple hint, which hopefully it should kind of scream at you once you see this, which is basically just a binary search. I also use the monotonic increasing, decreasing, right? So it's basically the same thing. You realize that this expression keeps decreasing as k increases, and you want to find a cutoff, which is pretty much what binary search does, right? So you binary search, think of what you would binary search on, what value you would want, what is the threshold you want. It should be fairly simple once you understand the problem clearly, and if you have a decent understanding of binary search does, it should be a fairly simple. Okay, I don't want to say simple. At least theoretically, at least thinking wise, it should be clear enough why this is a binary search problem. Then, as with most binary searches, actually implementing it is a slightly harder task. If you are comfortable enough to use your, I don't know if Java. I think most of the languages do have an inbuilt binary search function as well. So feel free to use that. But this is a case where I would suggest the opposite. Or rather, do both. Or do try, if your language has an inbuilt binary search function, great, use it. But even then, I would still recommend you to write your own binary search function, because writing binary search is an art itself. I would go to the extent to say it's an art. It's a very good skill to learn. So do try getting your hands dirty and coding binary search on your own. This is, I think, a general advice I would give. You do learn quite a lot of things when you just code binary search. So I would strongly recommend, even if you've gotten it accepted, do with inbuilt functions, do try coding a binary search function on your own if you've never done it before. ideally you should have, when you learn binary search, you should have learned it, but it's good to keep repeating with a few problems here and there. So do take this as an exercise and try coding your own binary search function as well. Cool. I think that's both the problems. Let me look at chat.
I think there was a clarification sort about binary search over answer, I think.
Okay.
That was probably in the context of when you were describing the binary search idea.
Okay, so Kaushik, I don't think using inbuilt ceiling function is an issue. And I mean, if you're passing only 3 test cases, it's probably there is something else which is the bottleneck. I don't know if you're getting time limit exceeded or wrong answer. I'm guessing it's time limit exceeded, in which case you should probably do something. It's not. I'm certain it's not the inbuilt ceiling function which is the issue in your code. There should be some other bug / suboptimality in your code which is causing the verdict or probably the larger test cases to fail. Kind of programming. Hello world. No, I mean like greedy and basic implementation were some topics which we saw, or rather no, so the assignments are kind of segregated into the topic which you're learning that week. So this week, so week 2 is basically sorting and searching. So the problems are based out of sorting and searching. It's not the case that all assignments will be greedy and basic implementation. Definitely not. When you're learning graphs or you're learning DP, you'll get problems from those topics. Bhupati, no, it's not exactly binary search over answer. Okay, I guess you could call it binary search over answer. It's a sure. It is binary search over answer. It's a very, I would say, it's a very simplistic binary search over answer, but yes, you're correct. Yeah. Arrange more live sessions. Sure, we'll do it. While taking seed of 2 integer numbers, seed of x by y, we should take not exactly sure what you're talking about. Hello world, can you what should you take care? I mean, seed of x by y is just can use both BFS and DFS. Smruti, okay, so that's a different topic. Maybe we will get to it later, but that is all BFS to optimize it. I mean, there are definitely, it's more that problem requires both different advantages of different persons. Okay, great. Misra, can you hear me?
I can hear you, but I think your audio was breaking just a bit in the last 30 seconds.
Okay, yeah, I just. Okay, yeah, I got my internet is, so maybe I'll stop my video. Okay, let me repeat the last 30 seconds. I was responding to. Who was I responding to? I was responding to Spurti about using BFS and DFS in a single problem. Just to be clear for others, don't worry. This is not. It's kind of like it's not in this week. It comes later. But the answer to that is it's almost never the case that we need to use both to optimize a solution. But it does happen in some problems that you will use BFS and DFS to get different advantages of their traversals and do something with it. But I don't think I've ever seen a scenario where you have to use both to just optimize somehow. Yeah. Cool. So should we go and discuss week 3 as well, or should we leave that for the next week?
Yeah, good question. I'm not sure. I think most people are still focused on the week 2 assignments, and I think the week 3 deadline would still be in the future on 21st August, right? So
correct. I think it's 25th So it's the 25th or 27th, I believe, is the deadline.
For week 3, right? Yeah.
Yes.
So in any case, it's after 21st. So maybe
Yeah.
we can, we could do it next week just to not overwhelm this discussion, I guess. I mean, unless you
Sure.
prefer, I mean, either way is fine.
No, I think it's also good to give people some time to solve it before giving hints. I wouldn't want to give hints.
Right. So I think we have addressed most questions in the chat. I mean, you either took them up or they've been addressed in the chat. I'm just going back to the sheet. I think there was one concrete question about Google Kickstart. Apparently, round E is coming up on 22nd of August. So I think the question is asking for general tips. So do you suggest anything during contest time? The person asking the question says, I get really nervous seeing how frequently people are getting into the leaderboard. So any suggestions would be helpful. So could you be looking at the leaderboard during that?
Yeah, I mean, okay. I mean, at least mine is going to sound like a very lame platitude. Don't worry about what others are doing. At least in Kickstart, I don't know which round is happening now. Isn't it
The
more of
one is
get into
E.
the
Hmm.
sorry? Isn't it
Yeah,
a level qualification rather than rank level qualification?
I don't know very much, but my understanding was that the Kickstart rounds happen throughout the year and are independent of each other. So I could be
Correct.
wrong about, but I guess yeah, this must be the next round that's around the corner. I'm not sure if you were asking if it is a round of a certain type or not, and I'm not sure if I got that.
No. My question was, I mean, okay, so there is no qualification, is what you mean.
Huh,
Okay, got it.
yeah, I don't think so. And I think it's still like a timed contest as far as I remember.
Uh,
So,
yeah, so okay, I think the main and rather the only use of rank list during a contest is just to see which problems are easy and which problem you should attempt first, second, third. I mean, you would like to go in increasing order of difficulty. Of course, in something like Kickstart, I believe they give you different points. So the points itself should give you an idea of which the easiest problems are. But sometimes setters do, means very rarely in contests like Kickstart, they might misassign points. I mean, something which they think is hard might end up being easy and vice versa. So it at some point you could look at the leaderboard just to get an idea. The other thing is sometimes so in Kickstart, just so there is this small and large thing, right? It's the same. It's the same format, right? Yeah. Okay. So that definitely helps because you can look at the leaderboard and check which problems small test data, small subtask has a lot of submissions. So then that probably has a simple subtask one, right? So, but there are problems in which even subtask one might be harder. So I think that's one good information you can get from the rank list. But apart from the just, I mean, just don't worry about what others are doing. Just concentrate on your own score, or just concentrate one problem at a time. Yeah, I really have not.
yeah. I mean, I just wanted to pitch in to say I completely agree. I think it doesn't really help, and especially if, if the way you would react to that is by feeling, if you are affected by it. I mean, for somebody who's watching it as a spectator and, they just see it and go, how cool is that? Folks are able to do things quickly. As a spectator sport, it's a different experience. But if you are actively competing, then I think the leaderboard should be completely irrelevant. And you could just focus all of your energy really on concentrating on the problems that you're solving. And the good thing about most of these code jam type contests is that I think the way the problems are ordered and the point system, it all already gives you an idea of the anticipated difficulty. And so hopefully you don't really need to look at the leaderboard at all. So I think that should be fine. So yeah, I'll probably move on to the next question. I think There was a relatively straightforward one about the kind of questions that come up in the final exam. Would it be MCQs plus programming questions or only MCQs? So there will be no programming questions in the final exam. But the questions may not always be just MCQs. You may have short answer questions with numerical answers. So you may have to write a number instead of actually checking off an option. And they need not also be multiple choice questions. They may be what are called MSQs in the sense that you may have multiple correct answers. So yeah, it'll essentially be MSQs and numeric questions. And if you look at the weekly assignments, that should be fairly indicative of the format. Sometimes in the weekly assignments, we will have very rarely a question that requires you to write some code to actually get the answer. But the final exam will not have any such questions. So it's going to be purely MCQ, MSQ, short answer numeric. So yeah, so I think that hopefully addresses that question. Now, there's another question which seems related. What extra effort do I need to put in apart from the lecture videos and assignments in terms of coding contests on various platforms other than references? And this is a request to increase the number of programming questions per week. Okay, I mean, my sense is that we are typically working within some general recommendations, given that this is an NPTEL course and it's supposed to be structured as such. So we need to estimate that, I mean, because this is, some people do this for credit transfer and so on. The reason I'm saying all that is because we are supposed to give you at least only a certain amount of official workload, and there's an estimate of how much that is supposed to be. So while we would just love to give you more and more practice assignment problems, I think we're just a little bit constrained by the format. But of course, we will give you, in fact, I think that's why the Discord community is so great, because I think learners in the course have actually been pitching in with their favorite problems from, at least this has already happened for binary search. So, so there have been a lot of suggestions in the forum, so you can go and try those out. And these are all on standard platforms, so you can practice. And we also have like an official list of practice problems, which we feel are closely aligned with the materials for that week. So you could try those out as well. So I think there's hopefully no dearth of optional practice material, but I think it'd be a little bit tricky to increase the sort of the official workload on the official graded assignments. So I hope you understand. In terms of other extra effort apart from lecture videos, I don't know, Arjun, if you have any suggestions, if you want to take that.
I mean, the simplest thing would be to just participate in contests. There are loads of contests happening across all platforms. Code versus CodeChef, AdCoder, Hacker Earth, Top Coder, and contests like Google Code Jam, Facebook Hacker Curve. So those, I mean, almost most of the contests do have easier problems, which you can, even beginners should be able to try. And of course, like solving problems on your own from practice sections is always never a bad idea.
Correct. I think that does make a lot of sense. Let's go back and see if we have any other questions. Okay, I think there's a general timeline question. If you can learn coding in a month and do medium level questions, I think that's a little bit hard to answer without a little more information about, if you're starting absolutely from scratch. And I'm not sure again what you would mean by medium level questions, but it does sound a little bit ambitious. But maybe if you're able to focus all of your energies in a month, then maybe. But in general, yeah, I mean, that's a little bit hard to answer without additional context. And I think some of the other questions we have are related to web development and seem a little bit out of scope. So I'm going to skip a couple of those questions. For those of you who put in those questions, I'm not sure if you intended it for a different course that you're already doing. So, please double check. And I think that probably wraps it up on the questions that we have received through the form. So Arjun, on the question about the timeline, sorry, if you wanted to say something, not sure if I interrupted you there.
Yeah, no. I do think it's a bit ambitious. Like one month is definitely, I mean, if you take medium, I don't know, let's say it's, I mean, like, okay, let's get the commonsensical medium, whatever you would assume it to be. I think it's definitely a pretty ambitious goal. I would say aim for something like in the first month, get very comfortable with your language and solve the easiest problems on the forums. And in the next couple of months, get the basic algorithms and data structures learned, because I'm guessing if you're learning programming, you're also not very comfortable with algos and DLs. So I would give a timeline of at least like 5 to 6 months to get to like an intermediate level. I think that's a more realistic goal to have. I don't want to be discouraging. I mean, like, all power to you if you really want to try it in 1 month, but
Yeah.
it's probably going to be a bit overwhelming to do all those things in 1 month if you're a total beginner.
Right. Yeah. I mean, again, without more context, like maybe if you already have, I mean, if you've already done your algo data structures course, and it's just that you need to brush up on some coding, but your main ideas are already in place, then perhaps yes. But I mean, basically, yeah, it's definitely not meant to be discouraging. It's the idea is to just make sure that you have a realistic whatever setup for yourself, because it might be more disappointing if you are not able to reach a goal that you set out with. So just be flexible about it and see how it goes. I think, as I said, a lot of it would depend on your specific situation, but yeah, by all means, give it a shot, and just feel free to be a part of the community and ask for help and work with somebody. I think all of that really really helps as you go along. So it saves time and makes your process more efficient, I guess. So yeah. All right. So I think
I think there's one question. Yeah.
programming
Yeah, from
assignment.
Learn to Code. Yeah.
Yeah.
So Learn to Code, I think I totally get what you mean by the second question. Don't be constrained and think that, oh, I should use sorting or binary search somewhere. There are multiple approaches to this. So this is supposed to be like a sorting problem. But if you have an approach without sorting, no issues. Don't worry about it. Um, yeah, so that's my answer to the second question. As for special cases, um, it depends on what your approach is, but I don't think there are a lot of edge cases. I'm assuming you mean edge cases. I don't think there are a lot of edge cases you need to worry about. Maybe look at n equal to 1. Maybe look at k equal to n, k equal to 1. These could be some examples. Maybe an example where all the elements are equal. These are some of the edge cases which I can think off the top of my head. But apart from that, I don't see, and I don't think there's any intended twist to the problem as such. So it's probably a more generic issue with the code rather than a specific case that we're missing. That would be my guess. Of course, I need to see the code to give a that definite answer, but that's my guess.
Cool. I think just try to address most of whatever else came up in the chat. In the chat. I think, yeah, just to make it clear, the prerequisites for next week would be disjoint set union. So we will include a separate video that recaps the uh, sort of the basic data structure. We won't really get into the proofs of the time complexities and why they work the way they are claimed to work, but at least in terms of just what the data structure is and how you would code it up, we will pick up a really, really simple illustrative example, and we will kind of go through the whole process. So even if it's something that you haven't worked with before, if you're willing to take some things on faith, you would still be able to go through all the materials in the upcoming week. So I know I'm a little behind schedule in terms of updating week specific prerequisites, but most of them should be available on the website soon, and we'll post an announcement in Discord as soon as the website has been updated. So I hope that that helps. Okay, so are there any other questions in the chat? Okay, I think we have largely covered everything in the chat. I'm just browsing through Discord as well as uh, the forum entries once again. I think we are largely good. Okay, so yeah, I think next week we will take up hints for questions from week 3, especially the programming questions. And if there are any other common questions that come up frequently on Discord or anything that comes in through the form, and of course, whoever is able to join us live will be able to pick up on whatever comes in through the stream, through the live chat. Okay, so I suppose we could call it a wrap then, unless Arjun, did you have anything else that you wanted to mention?
Not really. That's
Cool.
about it.
All right, so we wind this down here and we thank everybody for joining on
Thank
us.
you.
Appreciate it. Bye
Bye.
now.